Hello, I welcome you all in this presentation. This presentation is based on the topic weldability of the carbon and the alloy steels, and this one is related with the subject joining technologies for the metals. So, the topic is weldability of carbon and alloy steels. So, first we will try to understand the weldability word, and thereafter we will go for the carbon and alloy steels and how the weldability is affected by weldability of the carbon steel and alloy steel is affected by the various parameters related with these steels. So, weldability as it reflects its ability to get welded, or we can say ease of welding. But this ease of welding is defined under certain conditions, like ease of welding by a given process, by a given process for a given purpose, means the joint should satisfy the requirement of the purpose requirement or the purpose for which it is being made under a given set of the conditions, and the joint is made under purpose, and the weld is made, a joint is made under a given set of the fabrication conditions. So, these are the there are three things which are important, that a metal when welded by a given process for a given purpose under a given set of the fabrication conditions, then with which ease it can be welded, or ease with which it can be welded by a given process for a given purpose under a given set of fabrication conditions, that will determine the ease of or you can say that will determine the weldability of the metal, which is ease of welding. It is determined, and all this is determined by, you can say, quality of weld which is produced, like the metal system when joined by a given process under a given set of the conditions like this. So, what kind of the quality of the weld joint is obtained, how much efforts are required for producing weld joint, and third, the economic aspect or the cost of producing per unit joint. So, in general, if the efforts required for producing the given weld joint and the cost for producing the given weld joint increases, then the weldability of the metal system in general decreases. At the same time, if when the joint is made by a given process for a given purpose under a given set of the fabrication conditions, then what kind of what quality of the weld is made, that also determines the weldability or the ease of welding. If under a given set of the conditions of the welding, like process, purpose and the fabrication conditions, if the quality is poor, then we will say the weldability is poor or weldability is good. So, as far as the process is concerned, so if we see the weldability is being influenced by the process, it is the given welding process, the purpose and the fabrication conditions. So, these are the important things. So, like say metallic components to be joined by the welding. So, process is one thing, procedure of welding is another, purpose is third, and fabrication condition is fourth. Fabrication conditions is fourth. So, if we see here the process, the given metal A, say a metal is to be joined, two parts of the metal A are to be joined using a given process. So, the process may be our gas metal arc welding, it may be GTAW gas tungsten arc welding, SMAW sealed metal arc welding, SAW submerged arc welding, TIG plasma arc welding, laser welding, etc. There may be number of processes. And when a metal is welded a particular by a particular process, for example, when say this is simple carbon steel welded using the GTAW process, the quality is excellent because the damage to the base metal is minimum, weld size is minimum, and the soundness of the weld joint is extremely good. So, it results in a very good quality weld joint. But since the process productivity is slow, so if we will see just from the quality point of view, the weldability is extremely good, but if you see the productivity point of view, the productivity of the GTAW process is very low. Under the same conditions, if it is welded, like say there is another example, like if aluminum is welded using the sealed metal arc welding process, then the quality is extremely poor, because aluminum reacts with the atmospheric gases and it results in the very poor quality weld joints, even it may not be weldable also. But if the same is welded using GTAW process, then we may find that the joint is extremely good, because the inert gases associated with the GTAW process offers very good protects the aluminum from the atmospheric gases and results in the good quality weld joint. So, same metal welded using the two different processes can result in the different quality of the weld joints, and that in turn can affect the ease of welding or the kind of efforts that are required for developing the weld joint, the quality of weld which is made. So, this is how the process affects the ease of welding for a given metal. Similarly, the procedure involves the like say the kind of preheat being used, preparation of the base metal, like maybe edge preparation or cleaning of the fairing surfaces, then the process parameters, welding process parameters, post weld treatments. So, these are the different steps related to the procedure, like how much preheat is being used. If say material is very of the high hardenability, so if the proper preheat is used, then it will result in the good quality weld joint. If the preheat is not proper or it is less than the required one, then it can lead to the development of the cracks or development of the high residual stresses, which can degrade the performance of the weld joint. So, proper preheat has to be there, the proper kind of the edges must be prepared, otherwise the joint may not be complete. Like if very thick plates are to be welded, then a square groove geometry may not work. In that case, we may require that the edges are prepared properly, like say V groove, U groove, or the single V, single U, J. As per the requirement, different kind of groove geometries will be required. Proper edge preparation is so that is what proper edge preparation is. The fairing surfaces The base metal surfaces must be cleaned properly from the presence of the impurities. So, they must be removed in order to avoid the presence of the unnecessary gases in the weld metal or the presence of inclusions. So, if it is not done, then even despite of all best efforts, we may not get the good quality weld joint. Similarly, the selection of proper process parameters also affects the ease of the welding. If too high heat input is used, then it will degrade the heat affected zone, it will result in the undercut, it may lead to the lot of the thermal damage to the workpiece, a lot of residual and distortion tendencies will be associated with. PWHT or post weld heat treatment. So, post weld treatment involves like chipping off the slag or relieving the residual stresses or the heat treatment for annealing, normalizing, etc. as per the requirement. So, if these are not followed properly, then it may result in the joint something else than what we need, and that in turn may degrade the quality of the weld joint, or it may improve the quality of weld joint as per the kind of the procedural steps of being followed. So, proper procedure is to be followed for developing good quality weld joint, proper process is to be used, and if these are not used, then we will see that the quality of the joint is not up to the mark, or it is full of the issues like soundness, poor soundness of the weld metal, or unnecessary excessive residual stresses and distortion tendency, a wider heat affected zone, etc. So, similarly, the purpose for which the joint is made, the joint may perform very good under normal conditions, like if we take any simple mild steel, the mild steel weld joint may perform excellently very good under the normal ambient conditions, but if when the same is used under the minus say 20 or minus 30 degree centigrade under sub-zero conditions, then we find that joint loses its performance under the impact conditions very badly, and that happens due to the loss of the toughness under the sub-zero conditions, which is represented by the typical curve which is called a ductile to brittle transition temperature. So, here we have say 0 degree centigrade, minus 10, minus 20, minus 30 degree centigrade, and here plus 10, 20, 30, and the weld joint impact toughness if tested, then we may see that at a room temperature or above the 0 degree centigrade is very good, but as soon as we reach to the below 0 degree centigrade, we find that there is a drastic reduction in toughness of the weld joint. So, that is this y axis shows the impact energy in joule, and the impact you see Charpy V notch impact toughness of the material decreases, or of the weld joint decreases very rapidly under the sub-zero conditions. So, as far as purpose is concerned, MS weld joint performs very good under the normal ambient conditions, weldability is good, but if the same weld is used under the sub-zero conditions, then the joint will not perform and it will fail very prematurely. So, it will not be good for the weld joint. Similarly, so the temperature conditions, then load conditions. Under the static conditions, joint perform excellently, but some of the joints perform very poorly under the dynamic load conditions like the impact and the fatigue. So, especially the joints with the fillet welds perform very poorly, or joints with the high with the joints having the high stress concentration at the toe of the weld, they also perform very poorly under the fatigue load conditions. So, fatigue loading degrades the performance of the weld joint because they invariably contain they invariably have the stress ratios in form of the weld discontinuities or the stress high stress concentration at the toe of the weld. So, the purpose like the kind of loading conditions, service conditions, loading conditions, temperature conditions, and environmental conditions which may be dry or which may be corrosive. Since the heat affected zone of the weld joint experiences the changes metallurgically, also sometimes unfavorable transformations in the heat affected zone degrade the corrosion performance. So, sometimes the weld joint corrosion resistance is degraded. And so if the weld joint which is properly sound, good mechanical properties, but when it is used under the corrosive conditions it doesn't perform good, and that in turn leads to the reduced weldability from the corrosion resistance point of view of the weld joint. And similarly the fabrication conditions are also important, like what thickness is to be welded. Sometimes metal very easily weldable for 5 mm or 10 mm thickness, but if the same is welded for very thin sheet, like say 0.2 mm or 0.5 mm sheet is welded, it is found very difficult to weld and produce the sound weld joint of such a small thicknesses. Similarly, when we work with the very heavy thick plates like 40 mm, 50 mm, 60 mm, then these pose lot of problems associated with the heat affected zone due to the multi-pass welding. What we see that heat affected zone is developed due to the multi-pass welding degrades the heat affected zone properties very badly, and sometimes like say these cause the residual stresses, distortion, and the type 4 cracking problems or reheat cracking problems. There are various issues related to the multi-pass welding also, especially in case of the thick welding. So both thin and thick can impose various kind of problems even for the given metal, which shows very good weldability under given set of the conditions when thickness is not neither too low or not too high. So if from this discussion, if we see the weldability of the metal is not an intrinsic property of the material, but it is influenced by the various other factors which are associated with the process, procedure, the purpose for which joint is being made, and the fabrication conditions under which it is to be developed. So it is not an intrinsic property, but it is a relative one. For one set of conditions the weldability may be good, for another set of conditions. So it is a kind of relative term indicating the ease of welding for a given set of the conditions. So for the same set of the conditions different metals are welded, and then we may say that the A is good, then better than B, or B is better than A, like that. So but for that we have to define process, procedure, purpose, and fabrication conditions. Under the same set of the conditions, if the metal A, B, C, D are welded, then definitely we can do some kind of ranking whether B is better than A or C is better, A is better than C and C is better than D, like this. So this will give some idea about the kind of ease of welding for the different metal systems, but it cannot be ranked in very absolute terms, it is a kind of relative one. So now the factors that determine the weldability as far as the metals are concerned. So in general the metals and the weldability, how are they related, that is what we will try to see. So we know that there are certain characteristics of the metals like chemical, mechanical, and physical. These properties of the material metals govern or affect the ease of the welding significantly. Like chemical is about the oxidation tendency, how easily it evaporates. Then affinity with the atmospheric gases, then the structure of the metal. So these are some of the physical chemical properties of the material, and above one it is the chemical composition of the metal, means what are the constituents or elements that are there. Among the mechanical properties we have the yield strength, percentage elongation indicating the ductility of the metal and toughness. These are the mechanical properties. These properties basically determine the cracking tendency. High yield strength, low yield strength, higher elongation and good toughness resists the cracking tendency. So, those metals which are offering the otherwise different properties like high strength, low ductility, low toughness, they will show more cracking tendency. Similarly, the chemical composition affects the weldability significantly because it affects the solidification temperature range, it affects the various mechanical properties and physical properties. Oxidation, the metals during the welding normally the metal systems are heated to the high temperature. If they have tendency to get oxidized, then you will see that the weldability is poor. If it evaporates, the constituents in the metal evaporate in course of the welding due to the high temperature, then it will be leading to the difference in the chemical composition of the weld metal after the welding. Like this is metal being welded. So, when it is exposed to the high temperature and the fine surfaces are brought to the molten state, then some of the elements will be getting evaporated, and this evaporation will lead to the change in composition of the weld metal. So, this change in composition of the weld metal will degrade the mechanical properties, chemical corrosion properties and the tribological properties, etc. So, affinity to the gases, affinity to the atmospheric gases. So, those metal systems which have greater affinity to the atmospheric gases, they will be experiencing more the inclusions and slag formation related issues. So, they will be reducing the tendency for having the more inclusions. At the same time, they will also be having tendency to have more porosity. Structure of the material, some of the structures they offer the very good toughness, good yield strength, good ductility. So, some of the structures, if the structural modification takes place in the material like when the base metals are welded with the application of the heat, we will see that there is a change in structure of the metal nearby the heat in the heat affected zone. So, this and mostly it is the coarsening that is encountered. So, the change in structure is very limited, then the effect will be less, otherwise the change in structure can affect the properties of the heat affected zone appreciably. As I have explained, the mechanical properties, low yield strength, high elongation and the good toughness increases the cracking, reduces the cracking tendency. So, that is why it is good from the welding point of view at least. And physical properties like K, thermal conductivity, expansion coefficient, thermal expansion coefficient alpha, solidification temperature range STR, like temperature difference between the solidus and the liquidus, solidification temperature range. So these are the properties, and apart from this, like the melting point of the metal. So, in general, high thermal conductivity results in the lower weldability, high thermal expansion coefficient also reduce the weldability. Longer solidification temperature range also reduce the weldability, and higher temperature also reduce the weldability. I will explain how all these things are affecting to the weldability. We know that for the welding purpose, when we are applying the heat for the melting the fine surfaces, then we will be seeing that it will require more amount of heat because of the good K. The heat will be transferred rapidly to the base materials, it will require more amount of the energy and longer time to reach to the molten state. So, the increased amount of energy, increased efforts, increased set of the conditions required for proper melting if the thermal conductivity is high. This problem is mainly encountered in resistance welding processes where very high current is needed in case of the thermal conductivity of the metal is high, like in welding of the aluminum and copper, it poses the problem related with the high current requirements for the welding purpose. Similarly, alpha, thermal expansion coefficient, we note that during the welding we will be applying heat, and due to the application of the heat, there will be expansion and contraction. So, higher expansion and higher expansion and contraction in case of the high thermal expansion coefficient metals will be leading to the more residual stresses and distortion tendency, and that in turn will be reducing the cracking, that will be in turn increasing the distortion tendency and residual stress development, and thereby it will be reducing the ease of the welding. So, high alpha is also not good from the welding point of view. Now, solidification temperature range, we know that if the solidification temperature range increases, then it primarily increases the solidification cracking tendency as well as the liquefaction cracking tendency in the heat affected zone. That is why it is not favorable to have the higher solidification temperature range. Then the melting point, if the melting point is low, it is easier to weld because it will offer the lower lesser amount of energy will be required for the melting of the fang surfaces and to develop the weld joint. Otherwise, will require a lot of energy for the melting purpose. It will require a lot of efforts for for the purpose of melting the fang surfaces of the base metal to develop the weld joint. So, this is how the metal characteristics and their possible effect on the ease of welding, but all this was very generic in nature. Now, coming to the weldability of steels. So, whatever I have talked so far was the general aspects related with the welding. Now, if we talk weldability of steels, steels, we know that these are alloy of iron plus carbon. Carbon mostly occupies the interstitial spaces in such kind of alloys, and in simple carbon steels mostly we have the carbon in very controlled conditions, thereafter manganese, silicon, sulfur and phosphorus, all these are residual elements which are controlled within certain specified limits depending upon the kind of carbon steels. In carbon steels we mainly try to control the carbon only, like say for low carbon steels we have carbon less than 0.2, for medium it is 0.2 to 0.5, and then for high carbon steels it is greater than 0.5. So, mostly the high carbon steels are found up to say 0.5 to 0.8. So, this is the range for the different kind of carbon steels, and it is the carbon content that determines the properties of the steels in case of the carbon steels. But since the properties like the toughness and the ductility are very badly compromised with the addition of the carbon, this is what we can see as a function of carbon, ductility and toughness come down while hardness increases continuously and the strength increases. First increases up to say 0.8% of the carbon, thereafter it starts decreasing. So, this is hardness, strength, ductility and toughness. So, here we can say properties. So, to overcome this issue that with the very high carbon content although hardness increases, but it happens with the loss of the ductility and the toughness, and therefore, efforts are made to put in the alloying elements in the steels like vanadium, chromium, molybdenum, tungsten, etc. So, such kind of elements are added in steels. So, apart from the iron carbon, we add the alloy steels. Sometimes their carbon content is means a complete addition is kept with like say up to 0.3 or 0.5 depending upon the purposes. So, limited controlled addition of the alloying elements help to improve the strength without compromising much on the toughness and the ductility. So, in that case the steels are termed as the alloy steels when for specific purposes like enhancing the strength without compromising much on the ductility and toughness, alloying elements are added. So, we get the alloy steels. So, this is what is there about the carbon steels and alloy steels, and ease of welding in case of the steel is influenced by what? There are two aspects, like when a steel plate is welded, what we see after the welding, there are two aspects. One is the weld metal, how sound weld metal is being made. So, it is about the how clean a weld is, and another one in case of the steels primarily how about the properties of the heat affected zone. So, HAZ properties, these are the two important factors that determine the weldability in case of steels. So, the cleanliness of the weld means what? Cleanliness of the weld in case of the steel means it is about inclusions, porosity, and the heat HAZ properties, HAZ properties in case of like the kind of structure, hardness or the toughness variation which is encountered in the heat affected zone. So, these properties are governed by the various aspects. For example, cleanliness. So, if the weld is weld metal is very clean and heat affected zone made by after the welding heat affected zone developed after the welding of the steel does not have very uncompromising or very compromising properties, then the weldability of the steel can be considered good, because most of the time we see that heat affected zone properties are very degraded, the joint becomes very brittle and unstable, brittle and with the limited toughness or with the very poor toughness. So, here now I will conclude this presentation. In this presentation I have talked about I have tried to define the weldability term and the factors that affect the weldability as far as the those factors related with the metal systems, and what are the aspects related with the weldability of the carbon steels, and in which way the ease of welding of the steels is affected, and what are the various factors associated with the steels that govern their ease of the welding. That is what I will talk in the next turn. So, up to this now, thank you for your attention.